Okay, we're going to talk about section 11.1, which is Introduction to Calculus. It's finding limits using tables and graphs. So our goal in this section is to understand limits, notation, find limits using tables, find limits using graphs, find one-sided limits. Limits aren't too hard, but you have to follow along as you go. So limit notation is descriptors. Suppose that f is a function defined on some open interval containing the number a. The function f may or may not be defined at a. The limit notation. Now notice this limit notation here. The limit as x goes to a of f of x equals L. That means the function goes to some value. Is read the limit of f of x as x approaches a equals the number L. This means that x gets closer and closer to a, but remains unequal to a. The corresponding values of f get closer to a, L. We're not looking at what's happening at that exact point. We're looking at what's happening as we get closer and closer to that point. So, to find the limit of f of x by using a table, we evaluate f at chosen values of a. So we're saying, okay, we're going to look here, we're going to look here, we're going to look at different values as you go. If a approaches from the left, choosing values of x that are close to a but still less than a. As x approaches a from the right, we choose values of x that are close to a but still greater than a. So for example, here's a problem. We're going to find the limit of 4x squared as x approaches 3. We make a table of values. So when we look at this table of values, what I want you to point out here is this. Notice that here's 3. 3 is right there. Sorry, I think my pen working. 3 is right there. We're not looking at 3. We're looking at it getting closer to 3. So if we look at here, at 2.99, it's 35.76. At 2.999, it's 35.97. At 2.999, it's 35.99. Then it's 36. And then it's the value 3, I should say. And then it's 36.0024, 024, 240. What's happening? As we're getting closer and closer to 3 from this side, it's getting closer and closer to 36. As it's getting closer to closer from this side, it's getting closer and closer to 36. So for both sides, it's getting closer and closer to 36. So now finding limits using graphs. The limit statement as limit as x approaches a, f of x is equal to L is illustrated in this figure. So the first one we're going to look at is this one. If a, as x approaches a, here's the value a, here's what's my y coordinate. We're always looking for the y. Approaches a, f of x approaches L, so my function is getting closer and closer to this y value. Over here, this y value. At x equals a. The value of the function of is L, f of a is L. So what they're saying here is this. As my x coordinate gets closer to a, my y coordinate gets closer to L, and it could be the same value. I mean, from the right it equals this value, from the left it equals value, it could be that. Now the B case here, for B we got that as limit approaches a from this side, and this side, they both approaches L again. These both approach L. They're getting closer and closer to that y value. But notice, it's not equal to that value. So it's not defined at A. It's not defined there. But still, the limit is L. The limit is L because it's getting closer. We do not care what's happening at that point. We're worried about what happens as it gets close to that point. Now, the third case is over here. What's happening as the limit gets closer to a, you'll notice that it's the same thing. It's approaching L. So the limit is approaching L. So this is true. But f of a is a different value. That's not a problem. However, the value of the function is at a is f of a is not equal to the limit. Because we don't care what's happening out here when we do limits. We're worried about what's happening at the function right there. Now, if we're looking at this graph, it says, okay, find me the limit as x approaches a negative 2 of f of x. So a negative 2. So negative 2 is right here. So we go up here. What y value is right about there? If I look over here at negative 2, my y value is a negative or positive 5. So my limit is 5. Now I'm going to erase that. Oops, let's go get my eraser here. Now if I looked, it says f of a negative 2 is not 5. F of a negative 2 is 3 on this one. So the limit is 5, but my value is 3. Now we're going to talk about left hand and right hand limits. A left hand image, you'll notice a little small writing here. The left hand limit, the limit as x approaches a from the negative side, that's a left hand limit, is equal to L. Is read the limit of f of x as x approaches a from the left equals L, and is so called the left hand limit. This means that as x gets closer to a but remains less than a, the corresponding values of f of x get closer to L. Now the right hand limit, the limit notation f of x, the limit of f of x as x approaches a from the positive side equals L, is read the limit of f of x as x approaches a from the right equals L, is called the right hand limit. This means that x gets closer to a but remains greater than a. The corresponding values of f of x gets closer to L. The left hand limit and the right hand limit do not have to be the same. You'll see examples of that in the book. But if both of them are the same, then the limit at a is equal to that value. And that's what this is saying here. One-side limits can be used to show that a function has a limit as x approaches a. It says here, the limit of f of x as x approaches a is equal to L, if and only if both the left side limit, this is the left side limit, and the right side limit equal the same value. So if they equal the same value, then the limit at that number is equal to L. Now one-side limits can be shown that a function has no limit. So in other words, if the left side limit equals L and the right side limit equals M, where L and M are not the same, then the limit does not exist. So if the left and right don't equal, then the limit does not exist. So let's look at some of these. Using the graph of a piecewise function, f, to find each of the following, and state the limit of the function value that does exist. Okay, the limit as x approaches 0 from the negative side. So here's the x value now. You have to realize this is the x value. The x value is the y-axis. And now it says when you do a limit, you're saying what is the y value from the left side of 0? So here's 0. As x approaches 0, on the left side, the y value is getting closer and closer to positive 2. Now if I'm looking at a positive side, as x approaches 0 from the positive side, my y value is getting closer and closer to 1. Now the limit as x approaches 0 of f of x does not exist. If I can get an E show up there. Because the left side and the right side do not equal. Since these two do not equal, then it does not exist. F of 0 is where the solid dot is, so x equals 0 is 1.